Hello, this is Mrs. Scarpel, and in this video I'm going to show you how you can take the properties of exponents from our previous lesson and known values of some logarithms to evaluate a logarithm without necessarily having to use the calculator to find the value. So I have 3 examples here, and then I have another 3 on my next slide. Looking at these 3, I notice that my argument is never a power of 2. So I'm going to have to use these known values for log base 2 of 3, 5, and 7 to help me find the values of these 3 logarithms. Now 9, I know, is the same as 3 squared. So I can write this logarithm as log base 2 of 3 squared. Then we have that logarithm of a power property that says that I can make this 2 times log base 2 of 3. And since I know the value of log base 2 of 3 is 1.585, I can write log base 2 of 3 as 1.585 and use my calculator to find that value. So we have 2 times 1.585 is 3.17. So let's think about 10. The values I have to choose from are 3, 5, and 7. I can write log base 2 of 10 as log base 2 of 2 times 5. I can use my product rule of logarithms to write this as log base 2 of 2 plus log base 2 of 5. Now, knowing how logarithms are defined, that my argument is a power of 2. 2 to what power gives me the 2? Well, that value is 1. So I can write this as 1 plus log base 2 of 5 is one of the 3 values given to me. So 1 plus 2.322, and I can add these 2 values for a value of 3.322. Log base 2 of 12, well, 3 goes into 12 4 times. So I can write this as log base 2 of 3 times 4. I can then use that product rule again, log base 2 of 3 added to log base 2 of 4. Log base 2 of 3 we've used is 1.585. 2 to the second power gives me 4, so the value of log base 2 of 4 is 2. And now I have these 2 values that I can add together, and I will have 3.585. So the key is being able to break down the argument into factors so that we can find values using known values. Let's take a look at our next 3. You'll notice here we have some quotients. We have division happening. So what I can do, I see that I have a 7 and a 3 in my quotients. I also have log base 2 of 3 and 7 as values over here. So I can write this as log base 2 of 7 subtract log base 2 of 3. And that will equal 2.807 subtract 1.585. I'm getting these values because I know log base 2 of 3 and log base 2 of 7. I can go ahead and do that subtraction. 2.807 subtract 1.585 for a value of 1.222. If I take a look at log base 2 of 30 over 7, I can write this as log base 2 of 30 minus log base 2 of 7. Now I don't have 30 as an argument in any of the logarithms I'm given. I also know 30 is not a power of 2. I do know that 2 divides 30 evenly for a result of 15, and 3 times 5 equal 15. So I can write this as log base 2 of 2 times 3 times 5 subtract log base 2 of 7. I can then write this as log base 2 of 2 added to log base 2 of 3 added to log base 2 of 5 subtract log base 2 of 7. And if I replace each of those with the values they're equivalent to, log base 2 of 2 base and argument are the same, that has a value of 1, plus log base 2 of 3 is 1.585, plus log base 2 of 5 is 2.322, subtract log base 2 of 7, 2.807. So when we do that arithmetic, we will have 1 plus 1.585 plus 2.322, subtract 2.807 for a value of 2.1. And our third one, we have 486. So I'm going to try some things here. I'm going to see if 2 squared, which is 4, will divide 486 evenly. And it does not. What is 486 divided by 2? 243. So I could write this as log base 2 of 2 times 243. I'm going to check something. I think that might be a power of 7. So 7 to the third, is 343. Does 243 divide by 7? Not evenly. How many times does 243 divide by 3? That's 81. So let me see if it is a power of 3. 3 to the 7th is 2,187, so that's too high. 3 to the 6th is 729. We're getting closer. 3 to the 5th is 243. So I can write this as log base 2 of 2 plus log base 2 of 243, and I just found that I can rewrite the 243 as 3 to the 5th, and we know that the value of log base 2 of 2 is 1. With the quotient property of logarithms, I can take that exponent 5 and write it in front of my logarithm. So we have 1 plus 5 times the log base 2 of 3, which we know the value of log base 2 of 3. So now I'm going to have 1 plus 5 times 1.585. And using my calculator, I'm going to go ahead and take 5 times 1.585 and then add 1 to it, and we have a value of 8.925. So again, we were utilizing our properties of exponents, or rules of exponents, that we saw in a previous lesson. We combined those properties with given values of log of base 2, and we were able to find values without having to use the calculator necessarily and the log function on the calculator to do this. And this concludes this video.